Here we go. Introduction to trigonometry. You'll finally get to use those sin, cos, tan buttons you've been wondering about on your calculator. Introduction to trigonometry. Specifically, we're going to be working with sine of x, cosine of x, and tan or tangent of x. Okay. Now, what these guys are ratios and fractions that are going to be relating angles to side lengths. Here too, you must have a right triangle. Okay, just like Pythagorean theorem and the 30, 60, 90, 45, 45, 90s both had 90s in them as well. Okay, we'll zoom in here so maybe you see better. Now, sine, cosine, and tangent. These ratios look like this. I'm going to put an X in the corner. Some people will put a thing like this, which is called a theta. Theta just means missing angle. We're going to be using X more, but I just want you to be aware if you see something that looks like a weird zero, it could be a theta. Okay? And everything's going to be related to the angle that has a variable or a theta in it. Okay? So, from this angle, we are going to label the triangle. We're going to label the opposite side, the adjacent side, and the hypotenuse. Oh, hypotenuse, we know that, across from the 90. We're going to abbreviate that HYP. And the hypotenuse is always going to be the hypotenuse, really regardless of which angle you're playing with. But the opposite side is going to be the side that's across from your angle. Okay. We'll abbreviate that OPP. Adjacent is between the angle and the 90. And we'll abbreviate that ADJ. Okay. And the ratios that we're going to be playing with are sine of x or sine x. This is not sine times x, okay guys? This is sine of x equals opposite over hypotenuse. The cosine of x equals adjacent side over hypotenuse. And the tangent of x equals opposite over adjacent. Okay. This is the stuff that makes up trig right here. If you can remember that, boom, you're good. You will need a scientific calculator with sin, cos, tan buttons, okay? Cell phone is not going to be as user-friendly. You may have heard the acronym or SOHCAHTOA. And I like this one, I use it. What it stands for is sine equals opposite over hypotenuse. Ca stands for cosine equals adjacent over hypotenuse. And TOA stands for tangent equals opposite over adjacent. Okay. We can see SOHCAHTOA is just a way to remember these ratios. Sine equals opposite over hypotenuse. So, cosine equals adjacent over hypotenuse. Ca. Tangent equals opposite over adjacent. TOA. T-O-A. T-O-A. Okay. We will be using SOHCAHTOA to help us remember what we're playing with. And when you do it, remember, it's not SOHCAHTOA, SOHCAHTOA. Because there's an A in there. All right. Now, I'm going to show you a few examples with these guys again in our notes. I know I also give you guys example problems, but these are two examples that belong in your notes, and it's how we use trig to solve problems. Okay. And first we're going to be solving for a missing side. So the first thing you're always going to have to do is figure out what parts of the triangle are you going to be playing with. So you do need to label the sides. Opposite, hypotenuse, and this guy's adjacent. Well, the sides that we have are opposite side and adjacent side. Those are the sides we have some information on with 18, or that we're looking for, opposite. We don't know the hypotenuse, and we don't care about the hypotenuse. Okay? And if we remember our so, ka, toa, which one of these guys would we use? Adjacent, opposite? Adjacent and opposite are toas. Boom. So that tells us we're going to use tangent. So we're going to go tangent of our angle equals opposite over adjacent equals x over 18. From here, it's classic algebra. And if you take a second and put tangent 31 in your calculator, just do that real quick. You should get 0.6008, something like that. Now, if you do not get 0.6008, it means your calculator is in a thing called radians mode. Okay? So somehow, like DRG, that's going to let me pick degrees, radians, gradients. If you put tangent 31 in your calculator and you get something different, let me know and I will help you fix your calculator. Okay, because you have to be in what's called degree mode because we are playing with degrees. Okay, but it's a number, so we're going to treat it like a number. Well, we want to get our x by itself. How do we do that? Get rid of that, divide by 18. Opposite divide by 18 times by 18. So now we have x is by itself. X is going to equal 18 times tan 31, or tangent of 31. Put that in your calculator, and we get x equals 10.8. Boom, done. Now, you also might want to take some time to ask, well, to ask yourself, does the answer make sense? Well, if this side's 10.8, it's smaller than 18, and 31 degrees is going to be smaller than that side, so this side should be the smallest side. That makes sense, we're good. If you were to get something like 100, you should know something's wrong, because if this is across from the smaller angle, this side should be bigger. And if you get something like 0.851, well, that's really, really, really small, and 31 degrees isn't just amazingly smaller than this guy. This guy's going to be about 60. Remember we had 30, 60, 90s last chapter, or last unit section? Well, 31, 59. So it'd be 31, 59, 90. Angles are not going to be crazily off to have something like in the decimals down here. Another example. What if you're missing? So this one we had a variable on the top, and to get a variable on the top by itself, you just multiply it by the denominator. Well, what happens if you have a variable in the denominator? What do we do? Alright, so we are playing with this angle. We got a label, opposite, hypotenuse, and the adjacents up there. And SOHCAHTOA. We are working with hypotenuse and opposite, because we have a variable in hypotenuse, a number in opposite. We don't have any information or care about adjacent. So opposite and hypotenuse is so. We are using sine. Let's set it up. Sine 54 equals opposite over hypotenuse, 17 over x. Now, the easiest way to do this is a flip-flop. Okay? What I mean by flip-flop is when your variable's on the bottom, you literally have it trade spots with that guy. Okay? I can show you the algebra behind it if you're interested. What you're really doing is timesing both sides by x and then dividing both sides by sine 54, which works algebraically. But if you just remember, oh, I swapped the denominator with my other side, you're going to be just fine. It makes it a little easier. So x equals 17 over sine of 54. Put that on your calculator, and you're going to get 21 point something, but if you round it, 21.0. Okay. So these problems are about solving for a missing side. Tomorrow we're going to get into solving for a missing angle. But again, today this is where we're at. And I'm going to do a few examples. So if you want to see some more examples, make sure you check those out. Thanks for watching. Have a good day.